Today's Lunch and Learn. I'd like to begin by acknowledging the traditional owners and custodians of the land and those of the land we are on, the peoples of the Kulin Nation. I also pay my respects to their elders past and present. As you know, each week we talk to different specialists. Today, Alex will be talking with Thomas Rainger about the structural applications of eMesh on the Lilydale and Mooroolbark level crossing projects. Just to set the scene, last week I mentioned around 3.5 million tonnes of plastic is used each year, and this production of plastic is expected to double by 2040, which is quite frightening. We're seeing eMesh being used on several projects, and there's great potential for its use. So this is another way of using plastics. I'll throw over to Alex and Thomas to start their chat.
Thanks, Cheryl.
Thanks, Alex.
So, Thomas, can you tell us your title and what involvement you've had with the projects?
So my name's Thomas Rainger. I'm our Sustainability Advisor at our Manchester Road, Mooroolbark and Maroondah Highway Lilydale level crossing removals. Bit of a mouthful of a project, but essentially we sort of started the liaison process between Fibercon, who produce eMesh, and our sort of delivery teams in order to be able to get some requests for information and design change notices in, and then sort of like help them through, I guess, like procurement installation. So we have a jack of all trades. So there's probably plenty of sustainability advisors on the line, but hopefully I'll be able to answer a lot of engineers' questions as well.
Yeah, fantastic. So we're talking about eMesh today. Can you tell us a little bit about it and how you've used it on your projects?
Yeah, so just to take a step back, I guess. So eMesh is used as the replacement for steel reinforcing mesh on slab-on grounds, and also some other applications which we'll mention in the future. But at the SEPA Alliance, we sort of used it first in an island infill, just a small application in our Toorak Road project. Then we used it in the slabs underneath our bluestone pavers in the station forecourts for Lilydale and Mooroolbark stations. And then we've also used it at just under 10,000 square metres of shared user path at Cranbourne. So a couple of varied applications we've used it for so far, and looking for a couple of others.
So what is the appeal of using the recycled plastic fibres rather than a traditional steel mesh reinforcement? Yeah,
so to be honest with you, for us, it was just a saving in labour. So because we were doing the station work for our Mooroolbark and Lilydale stations under occupation, it was going to save us a shift of labour by not having to sort of lay the mesh down sort of the day before the pour or the shift before the pour. And yeah, by doing so, I guess it just saves in how many people's worth of like cost as well. So that was the main driver for it, but obviously steel is also one of our highest emitters on our projects besides concrete itself. But yeah, I guess for every 1 tonne of steel, we have 2 tonnes of carbon emissions. So it's sort of like a twofold factor. So anytime we can use like a substitute for that, it's great. And the same thing is like the recycled plastic fibres perform exactly the same as virgin like polymers. So yeah, it's almost like a no-brainer for using recycled plastics in them.
Yeah, fantastic. So what was the process that you had to go through to get the materials on site? Did you need any additional approvals, any particular training for the workers of how to use it?
We were really quite lucky in that we sort of started developing a relationship with Tony Collister from Fibercon to help us with our like sort of design of these elements. But essentially, because we're on either an MTM asset, we're just using the standard Vic Roads. I'll have to get the section reference for you, but it sort of just complies with their footpath specification. So it was sort of just like confirming with them the design requirements. So Tony did some loadings checks for the axles of the vehicles that we trafficking on them, as well as some like flexural checks for us. But otherwise it was just sort of like going through an RFI and a design change notice process. I mean, that took us 2 months, but we were also including a reduction in the thickness of the tile above it. So that's sort of why it extended out. Typically at like DCN process for something like this might be, say, 2 or 3 weeks. And just in order to, because we sort of were getting rid of some of the mesh, Tony had some recommendations for changing in the jointing systems between the different panels of the concrete for the slabs on ground. So by doing that and conveying to like the concreters, most concreters are like pretty comfortable and understand the different jointing methods, or worth their salt at least. So if they had some questions, I'm sure we could address those as they came up. But yeah, it was pretty straightforward. They were all on board. So we were really lucky in that scenario.
Fantastic. Were you just working within the VicTrack boundaries, or did you have any interface with council as well for the footpaths in particular?
So the footpaths, I think they're shared user paths. I'd need to double check at Cranbourne, but I think some of them are either, I think it's just within the rail corridor, given that it's sort of like line duplication, but I need to double check, but I'm pretty sure that most of the time it was just because we were dealing with the big road standards.
So you didn't need any council approval?
Yeah, and I just confirmed with design manager and EL that because we're sort of working within that big road sort of standards, we didn't need to submit any waivers or anything like that to them for like additional approvals, or sort of just like gets captured in the quality documentation. So we'll still need to, at the end of during completions, submit our test certificates and all that sort of stuff for the materials, just to demonstrate that they're compliant with the standards. But yeah, no additional approvals required in that sense.
Yeah, fantastic. Now, did you have any challenges or barriers that you had to face using the recycled plastic fibres? Is there some way you could explain how you overcame them, if you had some?
Yeah, I think that we're quite lucky in that we started with a small application on just as an island in Phillip-Toorak Road, and that was back in April 2020 when we sort of first started using the product, which just got everybody like comfortable with it. They sort of saw that there was one very small area where you could see the fibres on the surface, but everyone saw a sort of like a great finish. And then using it at M&M was the application where we're sort of going to cover that surface as well, then bluestone pavers, so we would notice even if there was some fibres at the top. And then after that sort of application, I think everyone was sort of comfortable with the finishes we were able to achieve to use it in the shared user path. So I think we're kind of lucky in that sense that we can start with a small application and go forward. And yeah, engineers have been great about it. I think one of the biggest challenges that we've had is just where we're able to use it. And I think just at M&M, so Manchester Road and sort of Mooroolbark and Lilydale, we've just got a lot of like exposed aggregate concrete out there, which means that unfortunately we're not allowed to use it. So the way they sort of make exposed aggregate concrete is by using a high early strength development concrete, and they spray a set retardant on top, and then they sort of blast away that like surface layer, revealing the aggregates as well, because they should be embedded within that like concrete. So bit of a bugbear of mine, because we can't include much like supplementary cementitious materials in our exposed aggregate concretes either. So I think one of the biggest barriers we've got is just trying to bring along our like urban designers and then for future projects, as well as looking at possibly different surface treatments we might be able to use. So, and hopefully that'll also solve some other problem ways, like if we use a product like OmniGrip or something where they use crushed glass and sort of I think helping the grip, but also some of them can just be sort of like architectural like finishes as well. So we've got strategies in place, but it's just bringing along some of our like stakeholders which are a bit hesitant, and that's mostly due to that like architectural or aesthetic finish.
Yeah, definitely. So will you continue to use this material in the future?
Yeah, as many applications we can for like slabs on ground. I think we've started costing those into one project that's sort of like still in the early stages of delivery, and then I think it's, I need to count on my fingers because we've sort of split one up into two, but we've got 5 projects coming up, and so we've included those like costings in there. So eMesh costs, it's sort of like double the price of like mesh, steel mesh, but you'll save that back in labour. So with I think it's about like $5 a square meter for an SL82 mesh, but with if you're using like a 5 kilogram per cubic meter replacement for eMesh, it's about $10 a square meter. So I mean, it's much less cost than the concrete and labour itself, but sort of doubles that in. So we sort of just allow that slight increase, and then hopefully we'll save it back for like in the labour anyway. So we'll keep using it on slabs and ground, but I think the next bastion to look at is using it sort of like some precast elements. And I know that I think there's one company based out of Geelong which has a type approved eMesh. I think they're just like CSR pits, but because it's down in Geelong, we've got to weigh up if, I guess, overall if it's better for our sort of like emissions, considering there are probably local like manufacturers nearby which we can draw on other like circular economy pieces where they might be using, say if we get our NDD waste and we separate out the sand, they might be using that same recycled sand into the pits. So using that sort of like circular economy, there's probably better options closer to us at the moment, just because they haven't gone through that type approval phase. The other big option is that our project, which is currently early stages of delivery, and then 2 of them coming up will be rail under solutions. So that's sort of like a rail trench. And then we have one sort of pedestrian underpass as well. We're still just figuring out if we're doing concrete piling, sheet piling. I haven't figured that one out yet, I don't think. But there are 3 projects worth opportunities to replace the steel reinforcing mesh in our sort of like, I guess in between the piles, you've got concrete, and normally that's like a steel mesh which they then use shotcrete on. So if we can replace that as well, there's going to be huge, I guess, areas. We're sort of just working through that. So because there's allowances in the sprayed concrete Vic Road like bridge standard, which sort of sits under the bridge standard. And I think that allows for steel fibers, but we're just sort of investigating the next steps for that. That's probably the next bastion. And yeah, I'm not sure if it's been done before, I haven't, but yeah, Tony from Fibercon probably pretty helpful in that respect as well. We'll be able to do some calcs to figure out sort of like the beam deflections on those, like in fields. Sorry, I've just haven't touched my computer, so it's gone to sleep.
we can still see you and hear you.
That's
all right. But that sounds like some really exciting opportunities. That's something we definitely need to keep an eye on to see how you go with those. So I guess I feel like the 2 of us have spoken very quickly, but I just wanted to see if you had any final words of wisdom, any advice to people who want to use eMesh on their projects?
I think just pretty much the same as like any application, we'd sort of say start early. So the earlier you include it, if we include it within design documents and all that sort of stuff, it sort of reduces the risk that it'll get missed, or that you'll have a tenderer that will return the quote and they won't include it. So at M&M, even once we did our DCN process, it was just a note noting you can replace the steel mesh with eMesh. And I guess because we were already under a lump sum by the time we did that, we weren't able to claim back the reduction in labour. So, I mean, the contractor made some savings for that one. But yeah, I'd say probably just like start early, and so we can include it in the scope and include it as like as the like design element. Don't be afraid to do that. So when we had our designers initial discussion, they were sort of just noting that they didn't want to limit us during construction, but at the same time was something we're sort of asking our design partners to include. So I think it's probably just don't be afraid in saying that this product will be used, even though it's a proprietary product. I think that was probably one of their main hesitations. But then also just noting that like they can't say that it can be replaced with steel mesh for whatever reason, if there's trouble procuring a product, or if they somehow got really great deal on steel mesh, which is far below eMesh, and they want to still use it. It's just the opposite process where they need to submit an RFI, which hopefully most people would reject using steel mesh instead. But yeah, I guess let's just start early, and yeah, we're quite fortunate as well and able to answer those like technical sort of questions, because it sort of came back that just not to get too technical, but the Vic Road standard sort of notes that there's meant to be sort of 5.6 kilos of like synthetic fibers to replace an SL82 mesh. But that's 5 kilos of macrosynthetic fibers and 0.6 kilos of microsynthetic fibers, whereas eMesh is only like macrosynthetic fibers. So it's these questions that sort of come up, which we're quite lucky to have somebody like sort of just like close those off and really like technical and like matter of fact way. But yeah, I'm sure that like if anybody as well has those sort of questions, to reach out and we can help you if we have to. It's always thousands of questions that will come out regarding a product.
Yeah, as soon as there's a new product, there's always a lot of questions.
Yeah.
So speaking of, Cheryl, do we open up now to some questions?
I think we can. Yeah. We've got 3 questions there. So the first one you may have addressed, it's from Damien Corporale. Is eMesh concrete suitable for spraycrete, shotcrete applications? You were talking about shotcrete before.
Mm-hmm.
How can finishing occur on batter slopes to ensure plastic strips are embedded correctly and not left exposed?
Oh, I need to double check the finishing with Tony from eMesh. I probably should have got Tony on for the session for these tricky questions. But I imagine it's pretty much the same process as treating any shotcrete surface finish, but there may also be some sort of like manual like surface finishing that you might not have to do with true like conventional like shotcreting. I'd need to take that on notice, but and we've been sort of advised that it's being able to use in it, but it actually hadn't occurred to me, so we'll with the first question I asked as well.
I think Alex, when we went to Childs Road, did they talk about they just brushed the concrete in the same way? Or I'm not.
Yeah, so in terms of finishing, so it wasn't what we were looking at wasn't it wasn't shotcrete, it wasn't a slope finish, but they did mention that there was just a slight change in the way that the concrete was installed, that they kind of had to finish it as they were going. They couldn't really come back, pour it all and come back and finish it, because once the concrete started to set, it was harder to push those fibers down. So that was just a bit of feedback. They just had to tweak the way they installed it just a little bit, just to make sure it was a smoother surface without the fibers poking out. And the other thing on that is, even if you do have a fiber sticking out, because it is plastic, you don't have the same issues of if there was steel fiber or steel reinforcement poking out, that will then have a serious detrimental impact to the structure or the footpath that you've poured, that it can cause cracking and other issues as the steel corrodes. With a plastic fiber, you don't get that.
Yeah, cool. And look, we can, Damien, we can shoot your question on to Tony at FibreCon. I guess, Thomas, that's the person to do that. The next one is, has recycled plastic been used to make geosynthetic grids for retarding reflective cracking in road pavements? That was a bit of a tongue twister. Did you get that?
I think so. I probably just need to default that, because I think previously my personal experience was having some sort of discussions with geofabrics who produce a lot of recycled plastic, at least geofabrics. I'd need to double check whether they've also translated that to their geogrids, but I'm not sure if the geogrids are also made in Australia or overseas, and they're sort of just import the geogrid, but I know they definitely make their geofabrics within Australia. So I'd probably just need to follow that up, but I'm pretty sure that we'd have a look online and see. I don't think there'd be any issues regarding like a quality perspective, considering it's sort of similar to like most recycled polymers. It would just be, they might have to do more selection process regarding the types of like, so I guess because eMesh is made through, I think mostly through PET products. So I think it just depends on which type of plastics, because I know that we can also have recycled H2PE plastic pipes and all that sort of stuff. They just need to be selective about it. But I haven't heard of one yet, but they might be in the process of developing. It might have just been released, but yeah, something to look up. I guess we'd probably just focused more so at the moment on the bigger impacts, because we're sort of still going through the process and introducing our, not changes, but just expanding our use of the products. So that's probably, again, if we can get the shot creating down, that's probably the next bastion from there.
Okay, well, perhaps, Alex, is that something we could follow up on?
Yeah, definitely.
Yeah, if you want to, PX Jackman, if you want to shoot Ecologiq an email at ecologiq@roadprojects.vic.gov.au, and that's Ecologiq with a Q, we can follow that up. There's also one from Daniel Cabell. Has there been much discussion about maintenance implications? We were chatting about that the other day, either by reducing lifetime of the assets or by being hard to replace if needed.
So I think that in regards to, I guess, like life cycle, I'm pretty sure most of the life cycle analysis that have been is it sort of gives a longer lifespan because there's not a steel to corrode within the slabs on ground. That obviously depends on which setting you're using, how aggressive they are, sort of stuff for like the steel itself that you're replacing. Because if you're in a low aggressive environment, it might be similar lifespans. But yeah, so from that perspective, they sort of like last. For the most part as well, I think these design elements are released like 20 or 40 years, depending on what we're using it for a footpath, or I think at least for our like station elements at M&M, some of the elements are sort of like 6 years design life. So hopefully we wouldn't be ripping up the bluestone pavers within any time soon, because they're pretty expensive. But I think for the lifespan, that's where it comes from. I know a lot of people have had questions regarding I guess like ultimate disposal of the material from the like life cycle assessment. And yeah, I remember Cheryl and Alex mentioned that you've sort of spoken with Alex Fraser and they're aware of the products and I guess looking at treatment options and sort of like how they would separate the plastic fibers from the crushed concrete. And were they looking at sort of, mentioned they were looking at sort of crushing it and then blowing them and capturing them or something. But the response for that as well is sort of like a chicken and egg scenario where they'll only start to develop like treatment processes for them if there is actually going to be an increase in the material use. So at the moment, like if there's only a couple of like meters cubed coming through, they might just decide it's not really worth it. We'll just sort of send it to a solid and landfill. But yeah, that's probably like the thing that the sort of aware of the changing products, and yeah, over time, I guess we've got the benefit of time as well, and that hopefully in the next 20 years we'll radically change the way we deal with waste, and hopefully the recycled first policy that Alex and Cheryl and Ecologiq and MTI sort of champion will help to address those processes anyway. But yeah, that's sort of like the life cycle questions we've had. I'm not sure if there's another question regarding like microplastics, which might be as well. But I'm pretty sure that for the most part, like during the service life, microplastics are sort of just like contained in the concrete. And because they're sort of like, for the most part, hidden from like UV or sort of friction, a lot of the things that normally cause like degradation of like plastics and then the sort of release into the environment, that's a bit of a like lower risk. Yeah, I think that's going to be probably with all of our plastic waste in the future though, so that there's just with response to that, I think that probably eMesh being encased in concrete is probably one of the lowest risk uses of that as well. I mean, yeah,
I guess even it's like a lot of those things, like you're saying, but when the need occurs, which was probably 20 odd years down the track, we'll be already working towards that, you would expect.
We started now, so hopefully we can come up with something in 20 years. So.
You would hope so. There's one more question just come in. Is it okay to use the same patching crack injection material as with regular concrete? I guess that's around maintenance, is it?
Yeah, I'd probably just need to double check. I think it patching is probably more of a like surface level. Depends on whether it's like a structural application and what the yeah, it's probably a bit more of a nuanced discussion than quick, easy one I'm able to give you. But for sort of like superficial ones, if we're sort of just talking about like, I can't know, I think of a word, but like just for say aesthetic purposes, it's probably not really an issue. If it's like structural in nature, I think it probably just depends on the like degree of the cracking. And then, yeah, it might be just a different methodology as well, depending on access and all that sort of stuff. So I think that it'll depend on the spacing of the fibers, but for the most part, we're only using small particle size sort of grouts for fixing like cracking and all that sort of stuff. So with high flowability, but yeah.
And I think that's important, that it's to note that it's not the concrete mix itself isn't changing. So the actual concrete will still have the same properties, whether it's a steel or a plastic. You say it might have a higher slump, but otherwise it's the same. So in terms of a patching concrete, it's still the same concrete. And typically when you're doing a crack repair, it's to stop water from getting into the steel, and there is no steel. So really, I can't see why you couldn't use the same techniques, and it may not even have to be as strict as potentially the typical techniques.
Good point.
Yeah, I think it probably depends. The last like sort of tech thing we were all quite lucky with as well is that the applications we've done so far have just been consistent and uniform, like depth, thickness in our slabs. So if it's something that has like an edge beam, so that's where it sort of like has a like thickening at the edge of it. eMesh, I guess, doesn't really quite work well around like sharp right angles. So Tony just mentioned that if we did that, you'd need to have sort of like a gradual like sloped change down to that thickness, which then I guess could increase the overall thickness of the concrete. So it just depends on the application and I guess what we're sort of using it in. Just there might be some slight design changes if you're using it around like edge beams. For like just sort of like even just building slabs on ground and all that sort of stuff. But in that application as well, I guess that's something to just be to consider, because then you'd have steel reinforcement as well. So that's probably just part of that process.
We've got one more question just coming, which will probably be the final one, from Daniel Cabell again. Do you consider eMesh as something that can replace all steel reinforcement, or is it more focused on specific applications or locations? What would the key reasons be for not being able to use it?
And I think you've just explained that quite well, that if there is an edge beam or a situation like that.
So there are some, for the most part, it's used on like slabs on ground. I don't think it's it's to replace mesh reinforcement rather than bars. I think there are other products that have been developed as like bar replacements. I haven't had too much of a look into those because our engineers are less comfortable with them at this stage. And there's also, I guess, 750 MPa steel, which isn't quite readily available in Victoria yet. It's available in Sydney, but not Victoria. That's sort of like things we could look at for those. But there's a couple of like slabs on ground where it just doesn't become, I guess, feasible. So at the bottom of the sort of rail trenches that we have, there's a sort of like a slab on ground across the uniform bottom of it. And you sort of just need to do a cost benefit analysis. So because it's a slightly more expensive product, if you're using it, if you still need to have, I guess, reinforcing bars to take primary, I guess, like bending moments and all that sort of stuff in there, it just becomes a little bit less feasible because you don't get that reduction in labor as well. You still need to have the laborers come in and install those bars. So I guess that's probably one of the like things that it's mostly just if there's sort of like steel mesh reinforcing only. And even in the things like the concrete reinforcing pits, they still need to have some steel sort of like bars along the edges of them. So it can be used in combination. But yeah, it's just then becomes a question of whether it's, I guess, feasible, worthwhile. But yeah, for simple like uniform thickness slabs on ground, it's almost a no-brainer. But yeah, just other sort of like factors to consider.
Great. Well, we're right on 1 o'clock. Thank you so much, Thomas. That was a great session. I'm just popping up the question slide here just simply because it's got our email address on it. So if you do want to follow up on any of the questions that came up at the end, or if there's anything else that occurs to you after this session, please shoot us an email and we can forward them on to Thomas or on to FibreCon. But once again, thanks, Alex and Thomas. It was a good session. We will post this on our knowledge share. Last week's isn't yet up, but I will endeavour to get them all up before Monday. So if you missed out on this, you will be able to go to our knowledge share and watch these sessions back. But once again, thank you, and thanks to everyone for. Oh, hang on, we've got one more question. Let me see if we can quickly answer this.
That was a tricky one.
Oh, no, that was just a thank you from Daniel to say thanks for your clear response. So that's great. Thanks, everyone. And we'll see you next week. And thanks, Thomas and Alex.
Thanks, Cheryl. Thanks,
Thank you.
Alex. Thanks, everyone.
Thanks, Thomas.